our third practice problem for intermolecular forces of organic chemistry. Here we've got a question 3 that says, the table below shows the boiling points of 4 organic compounds, represented by the letters A to D of comparable molecular masses. Now they've given us IUPAC names, so we've got compound A as 2,3-dimethyl butane. So we understand that is an alkane. It has 4 carbons in the parent and it has 2 methyl branches, one on the second carbon, one on the third. Then we've got B as hexane, straight chain alkane, just 6 carbons in the parent chain. Then we've got compound C, methyl propanoate. So methyl propanoate, that is the name of an ester. And compound D is pentan-1-ol, that is an alcohol, contains 5 carbons in the parent chain. Now for compound A and B, their molar mass is the same. Compound C and D, molar mass is the same. And if we look at boiling points, we notice from top to bottom the boiling points are increasing. But for compound D, it just says X or Y. So we're going to need a bit more information on that, which probably will come later on in the question. Now 3.1 says, compounds A and B are structural isomers. 3.1.1, define the term structural isomer. And here's the thing about this. Your definition for isomers can be asked in any one of the 3 parts of organic chemistry. It could be asked under naming of compounds, which is your first part, part A. Part B is intermolecular forces, and part C is reactions. So isomers can be tested across all 3 subsections of organic chemistry. Now your definition though for structural isomer, it is organic molecules with the same molecular formula but different structural formula. 3.1.2 says the boiling point of compound B is higher than the boiling point of compound A. Explain the difference in the boiling points. So if we look at compound B, I had mentioned that compound B is a straight chain alkane and compound A is a branched alkane. Now what we know is that the more branched a compound is, the smaller its surface area. So let's start off by actually mentioning that. Okay, we want to mention the structure of these compounds first. So I'm going to start off by saying compound B, which is hexane, is a straight chain alkane, whereas compound A, and I've given the name 2,3-dimethyl butane, is a branched alkane. So remember, this chain length refers to surface area. So in the same point, I'm going to say that compound B has a larger surface area than compound A. Or you can swap it around. You can say that compound A has a smaller surface area than compound B. But I am going to mention it in terms of B. So here I have it. B has a larger surface area than A. Now when you talk about surface area, the next thing that you need to mention is the intermolecular forces and then energy. So let's talk about intermolecular forces. Since B has a larger surface area, it should have stronger intermolecular forces than A. So we have B has stronger intermolecular forces than A. We're now going to mention energy. So we say that more energy is required to overcome the intermolecular forces in compound B than in compound A. And now we can conclude, since we were talking about compound B, we can say, therefore, compound B has a higher boiling point. So we mentioned the structure of B and A. Then we mentioned that because B is a straight chain, it has a larger surface area, so stronger intermolecular forces, more energy will be required to overcome those intermolecular forces. And then we mentioned that it has the higher boiling point. So the more questions that you do of this kind, the more you realize that there's a general structure in which your reasons are written. 3.2 says, define the term vapor pressure. So we have done this in the previous paper as well. Vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. 3.3, which one of the compounds B or C will have a higher vapor pressure? Give a reason for your answer. Now, when you are comparing B and C together, you can clearly see that B has a lower boiling point and C has a higher boiling point. But when we talk about vapor pressure is inversely proportional to boiling point. So if they're asking you which compound will have a higher vapor pressure, we are looking for the compound that has the lower boiling point. So between B and C, it is B that has the lower boiling point. So for 3.3, we're going to say B, and our reason is lower boiling point. We're now on to 3.4. 3.4 says consider compounds C and D. Will the boiling point of compound D be X, which is 75.5 degrees, or will it be Y, which is 135.5 degrees Celsius? Only write down X or Y. Let's first analyze what we have for C and D so we understand how this works. Now, firstly, compound D is an alcohol, whereas compound C was an ester. So esters have dipole-dipole forces, while alcohols have hydrogen bonding. Hydrogen bonding is a lot stronger than dipole-dipole forces, meaning that compound D is expected to have a higher boiling point than compound C. So between X and Y that's given to us, the boiling point should be Y. So 3.4.1, they just wanted the letter. We're going to say Y. And in 3.4.2, they wanted you to explain. So we're going to start off by talking about the intermolecular forces that compound C and D have. So we say compound C has dipole-dipole forces, while compound D has hydrogen bonding. Now let's talk about which one is stronger. So we know that hydrogen bonding is stronger than dipole-dipole forces. So I'm going to say D has stronger intermolecular forces than C, and our reason here is hydrogen bonding is stronger than dipole-dipole forces. Now that we've mentioned which force is stronger, we need to talk about energy. So we're going to say more energy is required to overcome the intermolecular forces in D than in C. And now we can conclude by saying, therefore, compound D has the higher boiling point. So that's it.